Welcome everybody to the Apalachicola National Estuarine Research Reserve's Sci-Cafe virtual series. This series is a platform to share information about the science that's being conducted in Apalachicola Bay in an informal and casual setting, bringing together residents and scientists to explore different topics. Our program will be about an hour in length, maybe a little bit less. We'll have time for discussion and questions at the end. You can put your questions in the question box, and Kennedy, who's our producer today, will ask the questions, or you can raise your hand and he can call on you. Today we have the Aquatic Preserve Manager, John Brucker, with us, the Apalachicola Bay Aquatic Preserve Manager. He's housed here at the Research Reserve. He will discuss the results of the Gulf Coast Ecosystem Restoration Council Apalachicola Bay Oyster Reef Restoration Project. It's a mouthful, but the reserve and the Aquatic Preserve took over the monitoring of that reef after it was put in place. Approximately 95,000 cubic yards of lime rock aggregate were placed on 317 acres, and the Aquatic Preserve staff has been monitoring it over the last few years. John's going to go into the data that they've found, and I think it's going to be very useful in the planning of future restorations. So, John, take it away.
All right, thanks, Nita. I appreciate it. So I'm going to turn off my camera just in case, but it is nice to be able to present a lot of our data. Thank you all for taking the time out this afternoon to tune in. So just give me a second here. All right, so hopefully everybody can see my screen. If you can't, please send a message in the chat to Kennedy or Anita to let us know. But let's see if I can get this to work now. All right, let's see. For some reason, let's see here, what's going on? It was working and now it isn't working. All right, there we go. Can everybody see the screen? Well, or Anita or Kennedy,
Yes,
can you
guys? I can see it. Looks great.
Oh, hang on. Here we go. All right, there we go. I apologize for that. Sorry. So just as Anita said, I'm the manager of the Apalachicola Bay Aquatic Preserve, which is part of the Central Panhandle Aquatic Preserves. It includes Alligator Harbor, Apalachicola Bay, St. Joseph Bay, and St. Andrews. We are approximately 174,000 acres combined. We manage these aquatic preserves across the 3 counties of Franklin, Gulf, and Bay. Anita mentioned we are stationed here at the ANER facility, and I have 3 staff that help me complete all of our mission critical programs. So just a quick background about some oyster restoration. The reason that we do oyster restoration is to promote reef development for oysters by restoring existing oyster reef habitat that has been degraded, depleted, or reached its productive lifespan. The placement of cultch material on existing oyster bars increases the settling of larvae and increases the oyster colonization. And when we say oyster cultch, we refer to any suitable hard substrate that will be suitable for spat attachment. When it comes to oyster restoration, we place cultch material in areas so we can create a 3-dimensional reef structure. So as I mentioned, it'll stimulate spat setting, it accelerates the recovery process, it increases natural productivity, it increases the sustainability of fisheries, and it enhances the overall ecosystem services. So the Gulf Coast Ecosystem Restoration Council, or GCERC, or as we commonly refer to as the Restore Project, because it was funded through Restore funds, or BP funds, Deepwater Horizon funds. So as you can see on the map here, there are reefs that were identified in Apalachicola Bay with the help of local oystermen, DAX, which is the Department of Agriculture and Consumer Services, and the Aquaculture Department. But so, just as Anita mentioned, 95,000 cubic yards of lime rock aggregate were placed on approximately a little over 300 acres in the fall of 2017. My staff and I were responsible for the monitoring of the success or progress of the reefs. It was our job to ensure that the designs were correctly implemented. We have performance criteria in our monitoring plans that enable us to determine success, and the data we use can be used for corrective action or future restoration efforts. So as I mentioned, it was a 2.5-year project. We were doing physical sampling of the reefs at 6 months, 1 year, and year 2. So just as I mentioned, the material was put down in the fall of 2017. So the first sampling took place in the summer of 18, right before Hurricane Michael. Then we've sampled in the summer of 19, and then through the fall of 2020 into this year's just into this year. We had a few setbacks with Hurricane Michael slowing down sampling, and obviously 2020 was difficult for everybody to do field work, so we wrapped it up this year. When I refer to the physical sampling, as you can see, we use scuba divers in the water, and we use a 1/4 meter quadrat, so 1/2 meter by 1/2 meter PVC, and we basically collect down to null. So in other words, we collect the rock material that is basically at the surface where we would expect oysters to be growing, and we collect down to where it's just rock material or mud. We collect 15 samples per monitoring site, so 5 on the port, 5 starboard, and 5 on the bow. Sometimes reefs will have more than one sampling point or midpoint, but each midpoint does get 15 samples. Things we record are sample weight. We measure shell height of live oysters. We do live and dead counts. And of course, we always do water quality when we're on the sites. The sample weight, shell height, and the counts, and those are typically done in the lab and not on the boat. We typically dive to collect the samples, and we bring the samples back to either process that day or we put in the freezer to work up at a later date. These are just some photos from the project again. The top photo with the quad underwater, that is what the reefs look like basically when the material was first put down. You can see that the limestone aggregate rock sort of looks like parking lot gravel, almost a little bigger. The 2 outer photos on each side are just photos again of divers in the water. You can see the photo on the left with the diver in the water fighting the current to hang on to the boat. As many of you know, diving in Appalachia is a lot more difficult than it seems. And then of course the clumps of oysters and the pile of oysters you see in the center of the photo, those are actual oysters from South Bulkhead on the eastern side of Apalachicola Bay that were collected this spring. Very large oysters, adult size oysters, legal oysters, and so we had some very encouraging results as the project came to a close. So as I mentioned before, we do, just in our data analysis, we count live and dead. We identify live oysters per size class, which is spat, seed, and then adult. Spat is 0 to 25, seed is considered 25 to 74, and then 75 and above is adult, I think. Right, there we go. Just wanted to make sure I was correct. And we count the number of spat, seed, and adult per site by round. So we had 3 rounds of sampling, again, 6 months, 1 year, and 2 year. We do a shell height distribution curve, and we use the DAX standard oyster management protocol to do estimates of live oyster density, so oysters per meter squared by site. And we also use the DAX protocol, and I'll explain this in a minute, to estimate the number of bags of harvestable oysters per site. So this will help in determining if these reefs are going to be able to be recreationally or commercially harvested. So getting a little bit ahead of myself there. But this is the protocol. So as I mentioned on the, just on the left-hand side, that the estimates that we do can be used to determine if the reefs can be harvested. So if we get estimates greater than 400 bags, it's healthy oyster reefs capable of sustaining commercial harvest. Greater than 200, it's a limited harvest, and less than 200, they're not able to be harvested. Less than 100 or none, it's considered depleted. Again, these are estimates, but it does help not just us, but the other partner agencies try to manage the fishery. So when we look at the data from this project, we collected over just about 13,000 pounds of sample material. So that includes oysters, shell material, and rock in each round. The average sample weight was a little over 10 pounds or just under 5 kilograms. So when we're collecting 15 of these, per location using scuba diving, my team and I are definitely, earning our paychecks out there. It's definitely some difficult work fighting currents, collecting this and going up and down in the water column. You can notice that there is a variation in sample material from site to site. In some years there's not much, other years there's more. A lot of that could be attributed to the shifting sediment in the bay, the shifting material in the bay, or it could just be that in the haphazard sampling that we do, that we just missed a spot where there was material and we landed on some mud or some sand. So in the first 2 rounds of sampling, spat-sized oysters were the most prevalent sized oysters, but in round 3, which is encouraging, seed size, so again that 26 to 74 millimeter range, proved to be the most prevalent class. So we are seeing that shift in size class you expect to see as the oysters continue to grow. In round 1, we collected 0 adults, but that's to be expected. 6 months isn't enough time for oysters to grow out there. But as the project went on, so at year 1, we only collected 7, but between last fall and this summer, we collected over 800 adult oysters. So definitely seeing some positive growth in the bay, and definitely encountering more adult or harvestable size oysters. Something to notice as well, the graph on the left, a lot of the time the number of live oysters was relatively the same, but something encouraging that we saw in the later rounds is we had a decrease in the number of dead oysters. A lot of the time during round 2 or year 1, we encountered a lot of seed size oysters, again in that middle size class, that had grown to that size and died. So on the rock material, we would find basically both sides of the oyster, so it would be open, but no meat inside. So in other words, it had died. So we were definitely seeing issues where they were growing to that size and just not able to make it to adults. So since that time, we've seen a great change, and that also is very encouraging. So just again, the east side of Apalachicola Bay, there were 9 reefs, and the west side only had 5 reefs. So we expect that the east side of the bay was going to contribute more live oysters, or just have more oysters just in general. More reefs, more monitoring points. It just kind of makes sense. As I mentioned, there were no adults collected in round 1. And in round 2, we only found adults on the east side of the bay. So over by the St. George Island Bridge, we didn't find any on the west side. But in this past time, we were finding adults at every reef except for North Spur too. And I'll have a graph or a table of that here shortly. So as I mentioned, we also do shell height distribution. We measure shell height of every live oyster that we collect and process. And in each round, or in each progressive round, we saw an increase in the average shell height. So again, things we expect to see as oysters continue to grow is that there's that shift from just the spat size, the small size, into the other 2 size classes, to where the reefs are functioning as you would expect. The increase in average shell height, coincides with the observed shift in the dominant size from spat to seed as well, in the adult size, just as I said. So, just as I told you guys earlier, we use the DAX management protocol to do some estimates of densities of live oysters. And so I've got some numbers up there, and the graph's a little busy, but things that really kind of stick out is that the estimated density of live oysters was much greater on the east side of the bay during all rounds of sampling. Again, we got greater numbers of oysters, so you would expect density to be more on that side of the bay. Something very interesting though to notice, if you look at the bottom right hand side there, the west side, the difference from round 1 to round 2 to round 3 of the estimate of the estimated density. So the west side of the bay was definitely showing some positive movement to where the east side of the bay remained relatively about the same. Again, these are estimates, and so it's just useful numbers to try to help manage the fishery or manage success. So this is using that DAX protocol. Just again, to remind everybody, 400 bags, greater than 400 bags is an estimate of a reef capable of sustaining commercial harvest, greater than 200, limited harvest, less than 200, not enough, less than 100 is depleted. You can see in round 1 that since we didn't have any adults collected, it makes sense that there are no reefs that could be estimated. Round 2, we only found a few reefs, or 7 adults, and so again, not too much. And both Cap Point and Cap Point Spur were on the east side of the bay, just to the east of the St. George Island Bridge. But if you look at round 3, when we collected 801 adults, you can see that Cap Point Spur, Peanut Ridge, and South Bulkhead technically meet the estimate requirement for being capable of sustaining commercial harvest. Monkey's Elbow is just below 400 but greater than 200, so it may be possible for a limited harvest. Those sites are all on the east side of the bay, but if you look at 8 Mile, it was just below 200, so it's not quite able to support commercial harvest according to these estimates. But over time that could increase. A very encouraging side of this is now that every single reef had some sort of value there in the estimates. While many of the reefs are still not capable of potentially being suitable for harvest, these are very encouraging results. Just that we're seeing adults around the bay. We're seeing them growing to that size again around the bay. As I mentioned, North Spur 2 is the only site that we didn't find any adults at. I don't really have any good reason for that, but that's the lone site. Another component of this project, we do side scan sonar mapping to determine reef area or reef extent. We map these reefs in the winter, spring of 19 and the spring and summer of 2020. We use side scan sonar off the back of our Twin V 19-foot boat. We use a Hummingbird Solix unit. Basically, we set up transects using the perimeter of the reef. We were given corner points of the deposition sites. The Department of Agriculture provided culching reports after all the material was down, so we knew where the material was supposed to be. So we created a pretty evenly spaced transects to be able to go back and forth to map the reefs. Data is imported, and we use a program called Reef Master to basically put all the transect lines together, sort of even them out and smooth them out. Reef mosaics, like you see on the right-hand side, they display the texture of the bottom, and they basically can show vertical height. So if you look at the top photo, you can definitely see the textures and the vertical height, so the shadowing that occurs there in sort of the bottom right of that the top picture. If you look at the top part of that top picture, you can see all the little pock marks, and you can see the little white circle in the center of that picture. That's sort of the one of the corner points of the reef. So you can see the changing of the bottom there from outside the reef to where they put down cultch material. And so visibly there you can see a change, but we also purchased a bottom composition software program to be added on to ReefMaster that we can actually identify different hardness levels of the sediment in the bottom to determine, or at least to estimate, whether or not it's the cultch material or mud or something like that. And I'll show you some of that here in a minute. The nice thing about ReefMaster is we're able to export these mosaics into Google Earth format or into ArcGIS format. We're able to use GIS to then measure the reef footprints. So in GIS, we basically look at the boundaries that were provided to us, and we trim everything up, and then we measure multiple times to determine the new area of the reefs. We have not done much in terms of vertical reef analysis, solely because we've had such limited growth in the first 2 years, and then in this final one we started to see some growth. But vertical profiling for vertical height is very much possible using our side scan unit. This is another reef. This is Hotel Bar. Some things to notice here. Again, you can see in the larger photo lots of the different tracks and shadows of where the cultch material is, or we assume it is. In the upper right hand photo, you can see as you zoom in, you see more and more textures. Unfortunately, if I would have zoomed in all the way to really see it, it'd be difficult for a lot of you to really understand what you were looking at. You can see how the transect lines, they definitely overlap. And you can see just the different shadows and the different textures. One of the difficult things about doing the side scan monitoring, especially in Apalachicola Bay, is the choppiness. A lot of the time you have to have really nice conditions to be able to do this side scan mapping. And if you look at the large photo on the bottom two treks, you can see the little triangle cut out there, and then the choppiness. That's just the example of a boat going by while we were out mapping just to chop up the surface. And it sometimes does distort the imagery that we have to go back out and redo it. Something else to notice in this big photo is sort of the circular patterns of the material that's down there, or the way the reef is constructed. And that, sometimes that could be due to the shifting currents, the shifting sediment, or it could be the way the material was put down on the reefs. In the original photos, or in the first couple photos talking about cultch in this presentation, you can see they use a fire hose to blast the cultch material off barges. And so a lot of the time, the material may fall where it's intended, but underwater it may drift or move or pile up unevenly. So sometimes we see these interesting sort of designs in the mosaics here. This is another reef. This is Cabbage Top. This is on the west side of the bay. And again, you can really see where there's some texture, where there's some vertical relief and shadows. Some of the rougher textures definitely indicate that rock material or that oyster material. And again, you can just really see how we combine all those transect layers and sort of clean it up. And we're able to get an idea of where the rock material, the cultch material might be, and where it may have gotten covered up or it may have gotten silted over. What we can do is, when we look at the images like this, our monitoring points are typically then in the middle of a small reef like this, so exactly in the middle. So if we we're looking at this map image, and we dove our site in the middle, we would expect to find some sort of rock material. If we were to dive on the outside, we would probably expect to find less rock material. So it's just a very useful tool to be able to look at some of the reefs. This is just another reef over on the west side of the bay. This is 8 Mile. And you can see again, there's some very interesting designs that appear in the imagery of the shifted material. You can see the shadows in the upper, or in the right-hand photo on the top part there. You can definitely see vertical buildup, some sort of ridging. There's lots of texture you can see that would indicate not sand or smooth mud, so some sort of rock material. It's difficult to really tell what things are when you're looking at these images, and that's why we have this bottom composition software, as I mentioned. So what we do, let me just go back one slide. So this is the 8-mile site, and if you look at the white dots in the left-hand photo, it's basically a rectangular site. So what we do in GIS is we take this mosaic imagery, and we run it through our bottom composition software, and we cut it off at the rectangular corners. And once you run it through this bottom composition, it assigns it hardness values. And for the crude analysis that we've done, by no means are we experts, we selected everything that was 50% or greater on their hardness scale to be suitable cultch material. A lot of that was determined by some of the initial mapping we did and some of the ground truthing we did to say, okay, when it's yellow to white, those are areas we found no material or very little material. And then greater than the orange to the black or dark brown, that's what we decided. So when we run it through this program and we put it into GIS, you can see the picture on the left. While it put it into the pretty teal colors, that the different hardness values are represented there. And so what we did is we selected the top 4, or again, just the top 50% hardness colors, make them all the same color, so you can see on the right-hand photo. So pretty much everything is red is what we've determined could or should be hard enough for spat settlement, and we measure those areas very carefully in GIS. We do it a few times, different staff do it, and then we take the average to calculate the area of each reef. So something that, so using this mapping, what we found is that just by measuring the corners of each reef, that actually only about 302 acres were cultched instead of the estimated 317 or 320. We're not really sure why there's that discrepancy, but that's what we found. This is a very busy slide, lots of information on this one. This is basically the measured acres. And what we found is that in each round there was reef lost, but just 75% of the planting sites in 2019 considered I'm sorry, I'm getting stuck in my words here. In 2019, the mapping average showed that the patches of substrate that were like hard enough represent 75%, so 226 of the 302 acres. And 2020, a little less. So we lost a little bit more between 2020 and 2019. So, but overall in this entire project, approximately 27% of the cultch sites have been lost. And we say that, and it's difficult without doing further ground truthing. But as I mentioned before, we can use that mosaic imagery to see if the reefs have been silted over, and that might be a reason that we say the reef has been lost or the cultch sites have been lost. It's also possible that the material sort of shifted outside of the original reef footprint, the original reef boundary. So if they were putting down the material and the current was strong and it shifted outside of that boundary, we may not have been able to map it during our project because of where our transects were set up. We tried to stay pretty much within those boundaries of each cultch reef with a little bit of overlap on the outside. But again, if it during the cultch deposition, if it shifted outside of that, or even during like Hurricane Michael or other major storm events, if the material shifted, it may not have been picked up in our mapping. So it's not to say that material has been lost out of the bay or completely buried. It just did show up in our mapping. So originally, the spatial extent of the reefs was supposed to be done at the 6 months, the 1 year, and the 2 year. Unfortunately, due to some unforeseen circumstances, we were not able to map at the 6 month mark. That is extremely unfortunate because that would have been right before Hurricane Michael, and we would have really gotten a great idea of what occurred between 2018 and 19 when we mapped again. That's just really unfortunate that we were not able to get that data, but we were able to get some great mapping data just in the past 2 times. So to get more accurate reef conditions, either more sampling locations or ground truthing the reefs via transects could be a better way. I know there's some new techniques being discussed on sampling to see if it's the same as using scuba, but that's the best way. Is we need to be able to get more samples across, each reef to really verify or to identify and compare with the mapping. The side scan files that we collected, we do a very crude analysis. As I mentioned, we are very far from experts. We are still learning as we go a lot of the time. And so it's very possible for mapping experts to be able to further process our data with either better software or computer programs, and that way they could, do more accurate reef determinations or determine what the bottom composition might be. With that, I will say thanks, and I will open the floor to any questions.
We've got one question here from Marcy Cockrell. She said that, I believe this was asked at about 3:20, which was when you were displaying your oyster count data. And she said that you didn't seem to have any error bars on your data. What is the variability in these data? And the significant difference in growth or abundance between sites?
Yeah, that's a good question. You're right. We do not have any error bars on that data. I do apologize for that. Someone pointed that out to us the other day. I do not have an answer to that question right off the bat. If you'd like to send me an email, I can send that information out. I can put my contact info back up on the screen here in a second.
Okay, there was another part to that question as well. How long will sampling continue to capture interannual variability in recruitment growth and survival? Surely a robust management plan for the wild resource will require some measure of annual variability to calculate a maximum sustainable yield.
Well, we are not continuing on any more monitoring. At this point, Florida State University is going to be resuming monitoring of these reefs. So in the future, if you are interested in any of that type of data, I would recommend contacting the FSU Coastal Marine Lab, the Apalachicola Bay System Initiative project. They're going to have some more data coming out about these reefs in the future.
Okay, was that all the questions we had?
We got a couple more rolling in.
Okay.
Becky Hodge asks, do you expect that the bay will be at a commercial status soon?
That's a great question, and I'm glad someone brought it up. I meant to sort of slide in just a little side note. As we all know, or many of us know, the bay was closed last summer by FWC until 2025 to try to help the bay recover. Between 2019, so basically between our round 2 and 3, which occurred during that closure period, is when we saw a lot of increased growth. So with the reduced harvesting pressure on the local oyster reefs that we have here, we have seen that increased growth and encouraging growth. So if things continue as they have shown, it's a very possible for the bay to recover sooner than later. It's difficult to say if 5 years will be enough, when it's going to be reevaluated, but the results that we've received are very encouraging. And if we continue to have the reduced pressure, it definitely allows the oysters to gives the oysters a better chance to recover.
We've got a couple more questions, but we have a hand raised from Joe Pearman. Joe, I'm going to go ahead and unmute you, and you can speak into your microphone.
Yes, have there been any kind of toxology tests in the bay as far as chemicals, that sort of thing?
You mean in the water or in the
Yes.
organisms themselves?
In the water?
Well, water samples are regularly taken at all different areas around the bay, whether it's DEP, FWC, or Department of Agriculture. And so lots and lots of water samples have been collected. There's lots of data, lots of information about nutrients in the water or chemicals in the water. So there is lots of that going on all the time.
Okay, I just didn't see anything. I saw where they were checking for nutrients, but I didn't see anything about the toxins.
Yeah, that's a good question. A lot of the time it depends on which organization is doing the sampling. And so off the top of my head, I'm not sure like who may be doing which parameters. But you could check with either DAX or DEP or FWC to see which gamut of parameters they are collecting for.
Okay, thank you.
Sure.
Thank you, Joe. We got a question from Stephen Dambach. What are the implications of the recent red tide?
Well, that's a good question. Right now, I don't know. We wrapped up our sampling last summer, and so I know FWC is continuing to monitor a lot of the reefs around the bay. I know that, as I mentioned, FSU is also monitoring the reefs. I really don't know off the top of my head if the red tide has impacted, any of the more recent numbers, the population or density numbers. That would be a great question to ask one of their groups. So that's a very good question to ask. I unfortunately do not know.
Right, Chad Hansen, I'm sorry, I think I missed your hand raised, but I'll go ahead and unmute you now and you can ask your question.
Okay, thank you. Yeah, thanks, John. This is Chad Hansen with Pew Charitable Trust, and thanks Anita and Ainer for hosting these webinars. I got a two-part question. I'm just looking at the, I guess, the data on the different size classes, and just thinking about like when a reef should or shouldn't be opened. Would this data would it be applicable to looking at the different size classes? So not only looking at just the adults, but setting metrics for the sublegals and the spat. And so in other words, maybe not opening a reef or waiting till all those size classes reach certain target levels before a reef may be open or not. I know that's changing as getting into the management, but I'm wondering about whether this data, monitoring type of data, could be used for that sort of approach.
I mean, that makes a lot of sense to me. We do our best to provide data and do this monitoring, to FWC, who is responsible for managing the fishery. That would make sense to me that the data that's out there and the data that's being collected, be used to, make good management decisions like that. So it's not just to look at the adults, as you said, but to look at the other classes to make sure that, we're not just seeing just a quick burst of adults and then everything tailing off again. So I think that the data that's been collected between FWC and myself, or my office, and then the continued data that's going to be going on in the bay, could be very useful to be looking at, all of those aspects, and probably should be used to determine whether the fishery should be reopened.
Yeah, okay, thanks for that. And then the second part, I guess it's kind of probably even actually similar, but given the variability in the differing trends on east and west and annual trends, or from sampling period to sampling period, might it make sense to use this data and this and the other monitoring data to look at multiple years, like achieving those target levels on the different size classes in multiple years versus 1 year? So if it reaches a certain target level for 1 year, given the variability of what's going on in the system, So just wondering if this monitoring program could be set up, or in conjunction with the other monitoring programs to apply that kind of approach, where you're trying to obtain multi-year target levels before you make a decision.
Well, so you're asking, I guess I'm a little confused as to what you're asking there. So you're asking, like, if our data could be used with other data to make these management decisions? So in other words, is
Well, I
it
guess,
comparable if you?
yeah, sorry, just because if you can continue this monitoring, but with if other agencies are taking on the monitoring of these reefs, I guess just based on your experience with the variability once you see from between sampling periods or over the course of time, would this monitoring be suitable to looking at the metrics that are looking at multi-year target levels versus single year? So I guess it's getting at the quality of the monitoring and how you can use that to fine tune the management strategies.
Yeah, well, so definitely the data that we're using, but the monitoring we're using, while you could have single year targets, definitely, as you mentioned, I think it's a lot better to have multi-year targets. For instance, this Restore project was basically a 3-year project, and we saw lots of variability. We also have another restoration project going on. That's in the Apalachicola Bay, St. Andrews, and Pensacola Bay systems. It's a NERDA, Natural Resource Damage Assessment Oyster Restoration cultch project. And we're seeing vastly different results in Apalachicola Bay on those reefs because of different material. So again, to go back to your question, so this kind of monitoring, I think it is more effective and is beneficial when you're looking at a multi-year process and across the different size classes than just trying to maybe single out single year successes or single year targets.
Right. Okay. Thank you.
Like 2 more questions. Charlie Conant says the map of the bay showing the reefs was very useful. How were the locations of the reefs determined, and is that map available online anywhere?
Great question. So I did mention it real briefly at the beginning. A lot of the sites were determined because the reefs previously existed and were harvested on. So a lot of the local oystermen were consulted about potential reefs they thought might be the best. DAX and FWC were involved in a lot of those conversations as well to identify the reefs that they thought could be the most successful, to receive the material. As I mentioned too, we do have that other cultch material project, and so sometimes some of the reefs are side by side or next to each other, and so there was a lot of cross-agency communication to make sure we weren't putting material on other material, and again to identify the most suitable locations. The map is available online. You can actually send me an email and I can send it to you. There's also a way to download our report online. If you go to the DEP's homepage, so if you go to floridadep.gov and you just type in SEACAR in the search bar, SEACAR, the SEACAR database is sort of our online database within the state of Florida for storing things, and you can get all of our data and monitoring reports. But if you don't want to go through all of that, you can send me an email or give me a call, and I can email it to you, no problem.
Susan Farmer asks a question that I believe you may have spoke on a little bit since she asked it, but when will the next round of testing occur?
Well, so they're actually out there right now. I can't speak for the results that the FSU Marine Lab has had since they took over the monitoring of these sites. I know that there's been some new sites that have been cultched and some new experiments have been set down by FWC and FSU to look at spat. And maybe even flesh content of some of the oysters to check for either toxins or bacteria. But I don't know. I know they're in the process, or it's still going on. So, but to answer your question, the monitoring is still continuing as we speak.
And the last one we've got at the moment from Peter Gallant. What does it mean that the west side of the bay is capable of raising an oyster off the bottom, but adults are not prevalent in your sampling?
Well, so on the west side of the bay, for some reason, we've just seen a lot less of the adult oysters. I don't really have a good reason as to why, we're seeing more. Well, we can hypothesize why we see more adults on the east side of the bay. Some of the material on the west side of the bay gets silted over. So when we may sample at one point in time and we see oysters growing to a certain size and they get silted over and die, they may not grow to the adult size. We do see oysters growing, but there's always more than one culprit that prevents oysters from growing to an adult size. So it could be a water quality issue, a predator issue, sediment issue, so on. And so it's difficult to say like why something won't grow on one side of the bay when it will grow on the other. There's always more than one culprit, but a lot of the differences we see is a lot of the material on the west side of the bay was silted over. So when you have reduced space for spat to settle, you just lose the chance for oysters to grow in that area. So there's no spat settling over there. Another issue we had, as I mentioned before, is when you get the over harvesting and more is being taken out of the bay than what's being naturally put back in, you just don't get oysters growing. And so while we're not a spat limited bay, there was a time when there just wasn't a lot of spat being put back in. But I think at this point, our data indicates that we're moving in the right direction. It doesn't mean that every reef is going to reach a harvestable point or even show adults, but we are hopeful for that.
That's all of our questions that we've got right now. I'll keep an eye out as we close out the meeting just to see if anything else shows up. And if your question if you didn't have a chance to ask your question, feel free to email John afterwards.
Kennedy, really appreciate that. And John, thank you so much for the wonderful information. It's very positive news. I think we all are anxious to hear what's going on out there. So I actually overheard John talking to our manager one day and heard this news. So I said, we need to have a Sci-Cafe on this. So thank you for bringing us those results. It is complicated. I think that if you follow the Apalachicola Bay Systems Initiative project that FSU is conducting, you'll be able to stay in touch with a lot of this data. They produce a monthly newsletter. So feel free to get in touch with any of us and we can help you access that information. It's all online. And wanted to let you know that this session has been recorded and will be available on the reserve's website. It's apalachicolareserve.com, and look under previous events. I put it in the questions or chat box here. And thank you so much for joining us. Our next Sci-Cafe will be in January. So look for our calendars and we'll get that out to you. So thank you so much. Any other questions?
Two last parting notes. Susan Farmer says, thank you, awesome talk. And Charlie Connett asks, can the entire bay have reefs built in it?
Well, certain locations, but there actually are a lot of historic locations. Actually, let me see if I can go back to that map. Can everybody see this map again? Did I do it right this time?
Looks good, John.
All right. So to answer your question, you can see that there are a lot of existing oyster bars all around Apalachicola Bay. And these are, ones that have been mapped or established for years and years and years. Certain areas are more conducive in the bay for the growth of the subtidal oysters. So, while I can't answer is the entire bay suitable, there are lots of different locations could be suitable for restoration efforts.
Okay. The, oh, I see another hand raised. What's that?
That's the same one we've had.
Okay, great. Okay, well, thank you so much, John and Kennedy, and all of our participants. We really appreciate your coming. And as I mentioned, it will be recorded and available on our website in a couple of days. Thanks so much.
Thank you, everybody. Please feel free to email or call if you have any further questions.